one block which is moving this way with the acceleration A. This side is purely vertical, and this one mass of small m is over here. Coefficient of friction between this and this is mu. If we are asked what is the minimum value of this acceleration so that this block sticks to this, then obviously the free body diagram is something like this, where this applies a force normal reaction onto this, and this applies back, this applies a normal reaction onto this. Mg is the weight which is trying to move it this way. So interlockings, they are meshed like this. Mg is this way, so this force will try to move this block in the downward direction. Because now they are meshed, so as a result, when this tries to move it this way, this applies a friction force in this direction, and this body applies a friction force in this direction. So the value of friction force is over here. Mg is trying to pull it down, and friction force is in the upward direction. If we are asked what is the minimum value of this acceleration so that this block sticks to this, then obviously we are using the maximum value of this friction force, that it is a limiting value, that it has just started slipping or it is just stationary, is one and the same thing. So in that case, this friction force is going to be equal to mu n. Now what is n? If this block is going with the acceleration A, then obviously this will also be going with the acceleration A, because both of them, they are moving together. And along the x-axis, if we see, the only force which is acting on this block along the x-axis is n. So this normal reaction is equal to m into A. If this is equal to m into A, now we look along the y-axis. This is x-axis, this is y-axis. If we look along the y-axis, then mg should be balanced by mu into n. Mu into n. N is what? Mu into n. That is, mg is equal to mu into n is what? N is equal to m into A. M and m get cancelled, so A becomes out to be g by mu. This is the minimum acceleration, that this block will be stationary with respect to this block. If you increase the acceleration, this will still be there. But if you decrease the acceleration below this g by mu, then this will start moving down. Now what we see is, if the acceleration is g by mu, this block will be stationary with respect to this block. This will not be moving down. Obviously, it will be moving along with this in this direction along the x-axis with the same acceleration as observed by a person on the ground, that is inertial reference frame. If acceleration is more than g by mu, this block will still be sticking at the same level. But if the acceleration drops below g by mu, then this block will start having acceleration in the downward direction. In that case, if someone asks what is the net value of acceleration, we will find that is what is this action in the downward direction, that is mg minus this limiting value of friction force. This will be the force in the downward direction. We can put it as equal to m into A dash. We can find A dash, and over here we shall be having acceleration same as that of this block. So onto this block there are two accelerations. One is along the x-axis, the other is along the y-axis. Using our understanding of vectors, we can find this A net in this direction, which is going to be square root, magnitude is going to be square root of this square plus A dash square, and we can find the value of acceleration also, and we can find this theta also.